An experimental rocket sled on a level frictionless track has a mass of 1.4 times 10 to the 4 kilograms. For propulsion, it expels gases from its rocket engine at a rate of 10 kgs per second, and at an exhaust speed of 2.5 times 10 to the 4 meters per second relative to the rocket. For how many seconds must the engine burn in order that the sled acquires a velocity of 50 meters per second starting from rest? We may ignore the small decrease in mass of the sled and the small speed of the rocket compared to the exhaust gas. So to solve this question, we could use impulse is equal to the change in momentum, where impulse is the force times the time that force is being applied for. And then the change in momentum is the mass times the change in velocity. So the change in velocity is 50 meters per second. So it starts from rest and then goes to 50 meters per second. So the change in velocity is 50 meters per second. The mass is 1.4 times 10 to the 4 kgs. So mass equals 1.4 times 10 to the 4 kgs. We are looking for the time. For how many seconds must the engine burn in order that the sled acquires a velocity? So we're looking for the time. So let's isolate for time. In this equation, we just don't know what the force is. So how can we find the force? So we are given our rocket ship, right? So this rocket ship expels gas. We know that it expels gas at a rate of 10 kgs per second. 10 kgs per second. And it also, the exhaust speed is 2.5 times 10 to the 4 meters per second. And this actually makes up our force. This actually makes up our force. And if you're unsure why it makes up the force, because you can just look at this. So kgs per second times meters per second make up kgs times meters per second squared, which is the units for newtons, which is the unit for force. So that's just to make it clear why we're using the expulsion rate and the exhaust speed to measure the force. So the force is equal to 10 kgs per second times 2.5 times 10 to the 4 meters per second. This gives us 2.5 times 10 to the 5 newtons. Now I sub in the force into this formula. So the mass is 1.4 times 10 to the 4 kgs. The change in velocity is 50 meters per second. And the force is 2.5 times 10 to the 5 newtons, which gives us a time of 2.8 seconds. That is our final answer. That is the amount of time it takes for the rocket to reach 50 meters per second from rest.